All right, we're going to do our notes tonight on 5.5 cosecant and secant graphs. Remember with these graphs that these are the reciprocals of sine and cosine respectively, and keeping that in mind will really help us and guide us in graphing these functions. So being that sine, that the cosecant of theta is equal to 1 over the sine of theta and reciprocate it, we can go ahead and make a box here and identify what these values should be for our cosecant graphs. So notice that sine is 0. Well, that's the same thing as 0 over 1. If we reciprocate that, we get 1 over 0, which is undefined. So we're going to have a bunch of points that are undefined. Everywhere where we had a sine, a value of 0, we reciprocate it, we are going to have now an undefined function. Okay, and the nice thing with our 1's, you reciprocate 1, 1 over 1 is still going to be 1. Negative 1 over 1 is still going to be negative 1. And then we have our undefined. So when graphing these, what I want you to do is go ahead and graph your sine graphs. And then from there, anytime you have a peak or a valley, you can go ahead and duplicate those points, and anywhere where it was 0, draw asymptotes to represent undefined, and then you'll notice a pattern. So our cosecant graphs are here in the green. So notice we draw in the blue. This is our sine of x graph. We're at 0, 0 there, at pi over 2, we're at 1, at pi, we're here, and so forth. So then for our cosecant graphs, everywhere we were at 0, we now have this asymptote here. And typically asymptotes we're going to leave and draw them as dotted lines. So notice we have an asymptote there, 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 and everywhere where it was 0. Where it wasn't 0 and we had these values of 1, we still have those points, but now we're going to have these graphs that go off into infinity direction. Notice that these graphs, as these values get really, really small here positively, when you reciprocate really small numbers, let's say 1 over 100, and you flip it, you get 100 over 1. So now you get really large values. And the same thing with some negative values over here. If you have negative 1 over 100 and you reciprocate it, you get values way down here that are going to be negative 100. So that's why you have these graphs that are going off seemingly to infinity, dealing with our range. So similar ideas here with cosine. Our cosine of x, everywhere that it was 1, the secant of x is going to be 1, and everywhere it was 0, it will be undefined. Negative 1 will be negative 1 again. 0 is undefined. And 1 is 1. When we look at our graph, again, our 1, where things were 1, they match up. Where things were 0, you have lines that are asymptotes. Asymptote, asymptote. And where things were negative 1, that holds the value the same. And then we draw what seems almost like parabolas, but they're not, because they don't go left and right forever. They go down forever, but they just get closer and closer to these asymptotes. So All the same transformations can be applied to sine and cosine graphs, meaning our x's can be shifted over by our b values, and our y's can be shifted over by our a and d values. The difference, though, is that we got to remember, if you divide something that is undefined by another value that's undefined, really we just have this, it's going to remain undefined, but we have to have this shift. So the undefined value, our y, is going to be very nice, and then we'll just have to shift our undefines by our y, our c value there. So let's go ahead and look at one here. All right, so the function I chose to graph here was 6 cosecant of 4x minus 2 pi minus 2. So just like before, we got to make sure we factor out our b terms, so our x is by itself when you're graphing sine functions. So I'm going to rewrite this as 6 cosecant of 4x minus, so I divide that by 4, I get pi over 2. Close this, minus 2. And I can see when I distribute this, 4 times pi over 2, I get 4 pi over 2, or 2 pi. So when I graph this, really what I want to initially look at is y equals 6 sine of 4 times x minus pi over 2 minus 2. Because the sine is a reciprocal function of the cosecant. Well, we did this. This was number 4 in our homework tonight, our problem set in class. So I went ahead and we got our 5 major points. So our 5 major points were pi over 2. So pi over 2, 5 pi over 8, and then 3 pi over 4, just going up by 1/8 pi each time. 7 pi over 8, and then pi. So we had values for my cosine graph at pi over 2. I was -2. And then for our 5 pi over 8, we were at 4. At 3 pi over 4, we're back to -2. And 7 pi over 8, we were down to -8. And then we are back at -2 for pi. So we got this curve that looks something like that. And then the graph will just be clones of this here. Let's make that a little infinite clone there. So the graph's going to be there, there, and so forth, and so on. So when graphing my cosecant, I'm going to go ahead and do the cosecant graph here in blue. Every point and valley are going to be the same. That point's going to be here. That point's going to be there. This point's there. So forth and so on. So those are points that are true. Get this out of the way. Okay. But where things would have been 0 before, because remember, on our sine graph, this would have been 0. This would have been 0. And so was this. Well, now, for our cosecant graph, those become undefined. So my asymptotes, I'm going to go ahead and put them in green. An asymptote should always be graphed with dotted lines. And then from there, I just understand that we're going to go away from them in a reciprocal fashion. So these are going to get smaller, so these get larger, getting very close to that green line but never crossing it. Getting really close to that green line, never crossing it. Same thing down here. Getting really close there, never crossing it. And be careful, it's not a parabola because we're not going off forever, but we're just getting infinitely close to those lines. So I can, making sure I don't cross my asymptotes. And that will be our reciprocal cosecant function for this one. So you can see, as long as you're really good at graphing your sines and cosines, applying these rules to our reciprocal functions will make those much more accessible to us. Thanks a lot. Have questions ready for tomorrow. Make sure tonight you print off that practice test, or not necessarily print it off, but start looking at those problems for our test on Thursday.